Hey everyone, this is Bhargav Suthar, and today we are going to learn what is a propositional logic. So in this session we will discuss some more logical connectives. So first one, what is a negation? See, its symbol is like this tilde. Now let P be any statement, then the negation of P, it will be denoted by tilde of P or this simply not of P, and it is read as not P. So negation of P, it is read as not P. Now see, if P is true, then it's negation. So that is not P, it will be false. In same manner, if P is false, then this negation of P, it will be true. See, this not P, it is a unary connective, as only one statement is required to form the negation. So there will be only one statement. For example, consider this P equals to I like to read. So there will be only one statement. So what will be the negation of P? So its notation will be not P, and it is I don't like to read. Simply just put the negation I don't like to read. Or in other way, it is not the case that I like to read. Okay, clear? Now what will be the truth table? So as see, we have only, it is a unary connective, so we will have only one statement. So just P and not P. So it is only one statement, so there will be only two truth values, either true or false. So T, F, now see, it is very easy. Now P, then not P. If it is true, then not P will be false. If it is false, then it will be true. So T, F, F, T. So this is how you can calculate or you can construct the truth table. Now the next conditional connective, that is if and then. Let P and Q be two statements, then the statement if P then Q, and it is denoted by like this P, this arrow Q, and that means P implies Q. Now P is known as hypothesis, the left portion is known as hypothesis, and the right portion is known as, that is Q, is known as the conclusion. Remark, P implies Q, it is equivalent to P is sufficient to Q, P only if Q, Q if P, and Q is necessary for P. So this is the equivalent forms. Again I am repeating, P is sufficient for Q, P only if Q, Q if P, and Q is necessary for P. For example, consider P equals to weather is good and Q is match will take place. So it is if then. So what will be the form? That means P implies Q. So that means if the first statement, weather is good. So if weather is good, and then second statement, so match will take place. So the final form will be if weather is good, then the match will take place. Note, see, P implies Q is true if both P and Q are true or both are false. Again, this P implies Q will be true if both are true or both are false. And this one is important. Now let us construct the truth table. So as it is not unary connective, so we will have two statements. So that means P, then Q, and this P implies Q. So as we have two statements, so there will be total four possibilities. So both are true, both are false, one is true, other one is false, and one is false, and other one is true. So T, T, F, F, then T, F, T, F. So T, 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 F, F, T, and F, F. Now P implies Q. What is P implies Q? We have just written here. P implies Q if it is true if both are true or both are false. So you can see that both are true. So in first row it will be true. Now TF, anyone is false, so that means false. Now next FT, anyone is false, so it will be false. And both are false, so it will be true. Now biconditional, that means if and only if. So let P and Q be two propositions, then see, P implies Q and Q implies P is called biconditional or double implication. Now it is written as the symbol P double implies Q, and it is known as P if and only if Q. Now see, P if and only if Q is equivalent to say P is necessary and sufficient for Q. Note, P double implies Q, it is true either both P and Q are true or both P and Q are false, and it is false otherwise. Again, it is true either both are true or both are false, and false otherwise. So this is also important to construct the truth table. So let us construct a truth table. So there will be how many statements? There will be two statements. So P, Q. Now see, it is P double implication Q. So first we'll construct P implies Q, then Q implies P, and then this P double implies Q. So P and Q. So again there will be four possibilities: TT, TF, FT and FF. Now see, P implies Q. What will be P implies Q? The first entry, it will be true. How? Because both are true. Now P and Q, see, it is true and false. So it is the hypothesis and the conclusion. So we need to just remember, or just, so we need to take care of the Q part. So what is the conclusion part if both are different? So TF, both are different, so the conclusion part is false, so it will be false. Now in same manner, F and T, it will be T, and F and F, it will be true. Now next, now TT, it will be same, and P double implies Q, it will be this P implies Q and Q implies P, so you will get TF, F and T. Now what will be the contrapositive implication? So the implication not Q implies not P. It is called the contrapositive of the implication P implies Q. Okay. So that means, that is, this implication not Q implies not P, and this P implies Q, both are contrapositive of each other. For example, see, if in a triangle ABC, this angle A equals to 90, then AB square plus AC square equals to BC square, and that is the Pythagoras theorem. And let's consider the second statement. If in a triangle ABC, this AB square plus AC square not equals to BC square, then this not A not equals to 90 degree. So these two statements are contrapositive of each other. Let us construct the truth table. So we will need P, Q, then P implies Q, then not Q, not P, and last not Q implies not P. So again there will be four possibilities. So TT, TF, FT and FF. Now P implies Q, it will be T, then TF, so it will be F, then FT, the conclusion part, so that means T, and both are false, so it will be true. Now same not Q. Now consider the Q. In Q there are TF, TF, so it will be FT, FT. Now not P. So in P we have TTFF, so in not P it will be FFTT. And in last, now not Q implies not P. Now see, both are true. Now see, both are false, then it will be true. Then TF, anyone is true, so the conclusion part TF, so it will be false. Now in next FT, so it will be true, and last both are true, so it will be true. Now see, consider this third column and this the last column. You can see that both the entries are same. So that means P implies Q and not Q implies not P. So both the truth values are same, so they are contrapositive of each other. Now let us discuss what is exclusive disjunction. Let P and Q be two propositions, then this exclusive disjunction, or we can say that it is the exclusive OR, is denoted by this P ring sum Q. It is denoted as P ring sum Q. Now the meaning is either P is true or Q is true, but both cannot true, or both are not true. So let us construct what will be the truth table. So again there will be four possibility, two statements, so P, Q and last this P ring sum Q, so that means exclusive OR. So there will be four possibilities, TT, TF, FT and FF. Okay, now see what is P ring sum Q, so that means either P is true or Q is true, but both are not true or both cannot be true. So you can see that both are true, but in this both cannot be true. So P ring sum Q, it will be false. Now TF, so it will be T, because anyone is true, it is possible, so it will be true. Now next FT, so anyone is true, so it will be true, and FF, so both are false, so it will be false. Thank you.